I guess a question for Waji, but for the group. But can you imagine an environmental event that would switch the Bay of Bengal over to being anoxic and denitrifying? What would it take?
I think it would take massive organic loading to get over the metabolic hole. I mean, if the respiration rate increases enormously, I mean, increases substantially to remove those traces of oxygen from the system, I think the bay would turn anoxic. But it hasn't happened. From what evidence we have, it hasn't happened in the last 35,000 years.
Could you imagine, I mean, given all the river input, if there were enough eutrophication, somewhat like the dead zone in the Mississippi River, that could switch it over and then cause some large change in ocean nitrate?
You know, it's a very interesting question. The Bay of Bengal receives enormous river runoff, as has been pointed out a number of times today. And India consumes enormous quantities of fertilizers, 18 million tons in fact today. And a large fraction of that is supposed to make it to the coastal waters. So you would imagine that the Bay of Bengal actually receives a large fertilizer runoff. It actually doesn't. If you look at the inputs of nutrients by rivers into the Bay of Bengal, it's not very large. That input is not very large. So eutrophication should actually, in principle, turn the Bay of Bengal, could turn the Bay of Bengal anoxic, but I don't think it's happening.
This question is for Jerry. You pointed out that you have not seen these increases in chlorophyll that are proportional to the upwelling that you see over there. One of the reasons could be iron limitation, as you said, but I wonder whether you know that the southwest monsoon has transitioned from a diatom-dominated system to a Noctiluca-dominated system. So I wonder whether you would be able to share some of your views on how that would affect the chlorophyll concentrations.
I don't think I have a view. I actually would say, Joachim, you're the guy to sort of address that question. I guess, and the one thing because I was running at the end of my talk, but on that sort of summary slide of the monsoon influence, upwelling and how chlorophyll responds, that Hofballer I had there was indicating that what we may have been seeing, which you picked up in the paper that you published, is sort of a decadal oscillation, and that first 5 or so years of the time series that were in the CWIFS data were high, and then it flipped back over that sort of 10 to 15 year time frame that I was now looking at. I don't know how that tracks with Noctiluca, and I think you or Helga are probably best positioned to sort of address that question.
I look at it as a kind of a system transitioning to iron limitation that Jim has spoken about, and silicate limitation. And that's why you get this dominance of organisms that really don't depend on either. And Noctiluca is one of them. So this brings me to my question to Nakwi. You made a comment that the oxygen minimum zone is not spreading. We have got data from more recent years, and I'm not sure which month you're talking about when you did the comparisons between Oman and the coast of India. But our recent data shows that low oxygen water shoals up to about 20 meters at times. And that is what is fueling the Noctiluca blooms that you see also in the southwest monsoon. It was only a winter phenomenon. Yes.
Of Oman?
Yeah.
Okay, our data comes from the southwest monsoon of 2004 that you were also on. Right?
That was not very close to the coast.
No, we had sample the station 16 and 23 for which the data were presented. Actually were from the inner shelf. The water depth was like 20 to 25 meters water depth. So they were really shallow waters. We did see nearly zero oxygen concentration, but not quite. The system was not reducing as it is off the coast of India. Okay, now what I was saying is that we have, I couldn't show that slide for lack of time, but we have this CATS time series site of Goa, which has been occupied, we've been occupying since, on a monthly basis, since 1997. Toward the beginning of that time series, we thought that we were actually seeing very strong redox conditions. And in 2001, I thought the system was going to collapse. That was the year when the demersal fisheries along the west coast of India almost collapsed. And half of the shelf in that particular year was covered with sulfidic waters. And we were very concerned, You also wrote that article in 9 Times in that particular year. What happened subsequently is that things have relaxed. We don't see hydrogen sulfide as often as we were seeing prior to 2005. It may occur, it may still occur, almost every year, but the concentrations are much lower. The volume of sulfidic waters is much lower. The fisheries have actually recovered almost fully. So we see a lot of interannual change. I think there is also a decadal change now. But we do not have compelling evidence to suggest that there is a secular trend indicating intensification of the oxygen minimum zone along the coast of India. And that is the most complete data set, most extensive data set which are available from anywhere in the North Indian Ocean. I also say that because, the Bay of Bengal, I went out to the Bay of Bengal the first time in 1976. It has been for 40 years ago. And I haven't seen the conditions change personally. So on that basis that I say that the system has been relatively stable.
Yeah, it doesn't agree with what Jerry presented, though, about Tim Rickson's work, where he shows that there is a huge expansion.
I don't think there's a huge expansion. Those are, single cruise data set. What I used in my 1990 paper was all the data that was then available. And if you could see that slide that I showed, where we had this station 20 and 23, which are just located, on either side of this boundary, you could still see the changes, huge changes across that boundary. And that boundary was still valid in 2007. Now, there could be, as I said in my presentation, there could be some fluctuation, some movement, even seasonal scale, on interannual scale, but by and large, that system has been fairly stable. That's very amazing to me, because, denitrification, as I showed, responds to very minute changes in oxygen. And under such conditions, if you have a change like, 0.09 micromole per liter per kg per year, the entire Arabian Sea should have turned anoxic.
Masha Prokopenko, Pomona College. I have a question for Jim about iron. Do you envision a feedback if increased export production would decrease the concentration of oxygen, which would increase availability of iron, and that would drive kind of a positive feedback for the years when there is higher production? It would get it even higher with more available iron.
Yeah, I think what limits that is the fact that the really high iron area within the Arabian Sea OMZ seems to be constrained more by the subsurface physics. As I mentioned, there is seems to be a front in dissolved iron just west of the 66-degree east meridian that's associated with a salinity gradient. And so I don't think that the flux of dust from above is going to have a big effect on that boundary. There may be other changes in circulation in the Arabian Sea that would affect that front and perhaps allow the high iron within that zone to penetrate further westward. But if it's tied up in that low salinity feature to the east, it's not available to be entrained into the upwelled waters.
Thank you.
Hi, I'm Mike Roman from University of Maryland. So I guess Mike or Jerry, do you know of anybody that have run IPC scenarios for the Arabian Sea, Indian Ocean? You know, will it increase the heating on the Tibetan Plateau and then have stronger southwest monsoons? Or these waters that are already 30 degrees, 32 degrees centigrade, which is at the thermal maximum for a lot of species, is it likely to go up?
Well, I have one partial answer to that. It has been documented that the Bay of Bengal is warming very rapidly, arguably the most rapidly warming part of the world's oceans. So it is warming.
Maybe you could join me in thanking all of our speakers for today.